In this video, I'll show you two examples on how to solve problems involving probability. Question 1 reads, in a certain cup production line, 6% are chipped, 8% are cracked, and 2% are both chipped and cracked. What is the probability that a cup picked at random be either chipped or cracked, or both chipped and cracked? Let's write out what we know. We know that the probability of a cup being chipped is 6%, which translates to 0.06 as a decimal. The probability of being cracked, which I'll denote as PR, is 8%, and that is written as 0.08. And the probability that you select a cup where it's both chipped and cracked, a total write-off, we'll write down the probability of C and R is equal to 2%, or 0.02. That being said, to find out the probability that you will select a defective cup, are these two probabilities added together. PC plus PR, where we have 0.06 plus 0.08. Adding these up, we end up with a 14% chance that a cup that you pick up at random will be defective. And of that 14%, 2% contain both of the defects. So to find out how many are only chipped or cracked, we'll have to take this amount and subtract it from P, C, and R, which is equal to 0.02. Subtracting these two, we end up with 0.12, or 12% probability that the cup that you pick up has only one type of defect, not both. And so that's the answer to question 1. Question 2 reads, if the probability is 80%, P is equal to 0.8, that a single part drawn at random from a production line is accepted, find the probability that exactly 6 will be accepted if 10 parts are taken. So if 80% are good, which we denoted as P is equal to 0.8, then 20% are bad. And we denote what's rejected as Q. We want to find out the probability that 6 will be accepted if 10 are drawn at random. So our n value is 10, and 6 represents the successes, which is denoted with the letter X. Just so you understand what's happening, they want us to find the likelihood that 60% are good when 10 are selected, even though in the perfect setting, it's 80%. To do this question, we'll need to use the binomial probability formula, and we'll do that by substituting what we know. P at 6 is equal to n factorial, so 10 with this exclamation mark, bracket, 10 minus 6 factorial, 6 factorial, times P to the power of 6. So we have 0.8 to the power of 6 times Q, 0.2, 10 minus 6. Let's use our calculator for this. We have 10 factorial, and that can be accessed by clicking Shift in this button, divided by 4 factorial times 6 factorial. Then we multiply this by 0.8 to the power of 6 times 2 to the power of 4. And this gives us an 8.8% chance. 0.088. You can even round that up to 9. 9% chance that if you pick 10, only 6 will be accepted, even though 80% of the time at random is a product accepted. And so there you have it. That is how to solve problems involving probability.